Let's go to question number 980, unique path 3. This is hard question. Let's get into it. On a two-dimensional grid, there are 4 types of squares. The one represents the starting square. There are exactly 1 starting square. There are only 1. 2 represent the ending square. There is exactly 1 ending square. 0 represent empty square we can work over. -1 represent obstacle that we cannot work over. Okay, return the number for directional work, top, up, down, left, right, from the starting square to ending square. That work over every non-obstacle state except 1. So we need to work over every 0, right? So let's see example 1. Okay, now we start from here. This is start point, and this is in the point. This is obstacle. So first way is start here and then going here, 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 and finally we arrived here. At that time we passed all of 0, so we count 1. Another way is going here, 1, 2, here, 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 here. So finally there are 2 ways. How are we gonna do? Yeah, that's right. Okay, let's start with the proposed solution. Actually, I think the proposed solution is also enough. Time complexity is the exponential, but quite good result. So today I'm gonna use DFS. Yeah, with the equation, and then first I'll find the starting point and the ending point, and then next I will, when I scan whole of matrix, I also calculate number of zeros, and then when it move to the 0, I will deduct 1 by 1, and then when I arrived here and the left 0 is 0, at that time I will increase the count. And then when I moved there, I marked that this one is visited. Visited, I think the -1 is the good number because it did not go again. So after going back, I will release it to the original number. Okay, let's start improvement now. First we need the counter. Yeah, I will return this counter. And second, we also need a 0 counter, 0, and then start point. Row start is none and column is none. Also, we need the end point. Also, none, and then okay. I think now is almost okay. I think this is now is enough, and then. Okay, let's scan the matrix. Okay, make the 2. M is length grid. This is max low, and the max column is N. Then grid 0. Then I will scan the matrix. And then if matrix row and column is 0, at that time I will increase 0 counter, and then matrix column is 1, that is start point, right? Start row and column, and row and column is and the point at the time in row and column. I think now they're almost done. Then we make the DFS and the past first at the start point, start row and start column, and then so 0 count number of 0. Can I make DFS? We'll list the row and column, and zero count. Then I will use global mn count and end. Start no need, because start we received from argument, right? And then let's make the base case if row is and row and column is, and that is we arrive at the end point. We check if not zero count is 0, and I will increase the counter, right? Then return, and then I would like to only check the boundary. So if the maximum is n and smaller than row, and that is the bigger equal than 0, and then column and matrix column must be not obstacle I will not go there that time. Then okay, now if we are in boundary matrix, first I will check if current matrix row and column is empty, that's 0. I need to deduct 0 count. Do we need to check the below 0? No need, because I will use visited check, so it cannot go to the visited again, so no need to check the below 0. Below 0 is this one. This is no need. Okay. Next. And then I have to finish that, and then okay, let's visited check. I need a temp put current matrix value, and then matrix current value change to obstacle to mark visited, and then row and column and 0 count. And then after going back, popping the system stack, I will roll back our column to original value, change it. I think it's almost done. Let's finally check gamis and grid. Okay, count 0, 0, start and null, and then 0 is 0 count 0 is empty, right? And then 1 is start point, 2 is end point, and then TFS start is start point, and then 0 count. Okay, it's good. And then row column 0 count, non count mn count, end. Okay, row and 0 and the column and 1 at that time. That is, we are here to end point. If the 0 is 0, that means I count increase 1. And then in boundary of matrix and matrix 0, 0 count minus 1. Okay, matrix. Okay, looks good. Now matrix is grid, but I saw all matrix, right? Only this one is grid, so I will change matrix. Okay, looks good. Okay, time complexities, let's check. We start from here and then we need to able to go to 4 direction, right? So go to there is it take n. So time complexity is 4 to the n. Time complexity is equal 4 to the n, and then space complexity is linear because system stack recursion systems still use same amount of number of metrics. And then is there any other no data structure? Okay, thank you.